Good morning to all. Myself, A.D.M.COLEEGE, working as an assistant professor in chemistry, A.D.M. College for Women, NAGAPATTINAM, Autonomous. My topic is petroleum in industrial chemistry. First, we see introduction about the petroleum. What is petroleum? Petroleum is derived from the term rock oil, which is derived from the Greek word rock. Petra means rock, oleum means oil, so that is called oil from rock. It occurs below the surface of the earth. So all the natural resources we get from the earth. One of the resources petroleum. So it is a mixture of hydrocarbons. It may be a saturated or unsaturated hydrocarbons. It contains some certain organic compounds, oxygen, nitrogen, sulfur, etc. It looks like dark color crude oil with offensive odor. It smells like a offensive odor. Next, it has three types: solid, liquid and gas. Liquid petroleum is called natural gas. Solid petroleum is called bitumen or pitch. Petroleum gas is called natural gas. Next, we see about the advantages. What are the advantages of petroleum? First one is it is easy to extract. Yes, it is easy. Extraction is very easy for petroleum. Next, transportation. During transportation, it is easily carrying through vehicles. Next point is petroleum fuels are quite clean. Yes, it occurs from the earth's surface, so it is quite clean. It has some stable energy sources. Cost also efficient. Next, disadvantages of petroleum. What is disadvantages? It is environment unfriendly because it releases some carbon dioxide in the atmosphere, so it pollutes the environment. Next, releases hazardous toxins. Some of the toxins are carbon dioxide, carbon, etc. So it will also affect the environment. It contributes to the acid rain. So we are using so much of vehicles nowadays. So it will create some toxic pollute to the atmosphere. We get acid rain. Next one is transportation spills. What is transportation spills? During transportation from one place to another places, it will damage the road. So sometimes it will affect the roads. Next one, it pollutes the water. So it is actually occurring in nature. Sometimes we used to digging the earth surface, it will mixes in the water, so it can pollute the water also. Next one is refining. Refining is more important in petroleum because due to refining we get some byproducts in the petroleum. Refining is a process converting crude oil into useful products. So crude oil is converting here. It gets LPG, gasoline, kerosene. What is LPG? LPG is nothing but liquefied petroleum gas. It is used for domestic purpose in households. Gas is in the fuel as a vehicles. Kerosene is used as a domestic purpose. Next one, it is composed of different hydrocarbon molecules. I already told it has some mixture of hydrocarbons. It may be saturated or unsaturated hydrocarbons. Next one, the proportions of different refinery products will vary with the changes in the types of soil. Yes, here in India, some type of soil present. In other country, state, type of soil is depend on the natures of the state. So it will change in the proportions. Next, refining proceeds through separation and conversion to finished petroleum products. So due to refining, some separation and conversion of petroleum also processed. Next, here the tabular column shows that some refining products of petroleum we get. Due to refining, here some products are obtaining. First one is petroleum ether. It having the boiling rate 30 to 70 degrees Celsius. It is used as a solvent. Next, petrol. It have the boiling range 70 to 120 degrees Celsius, which is used as a motor fuel. In vehicles, petrol used as a motor fuel for two-wheelers, four-wheelers, etc. Next one is benzene. It has a boiling rate 120 to 150 degrees Celsius, which is used for dry cleaning purposes. Next one is kerosene. It has a boiling rate 150 to 300 degrees Celsius. It is used as a fuel in domestic purposes. Next, gas oil or heavy oil, which have the boiling range 300 to 350 degrees Celsius. Fuel for diesel engine. Next one is lubricating oil. It has the boiling range 350 to 400 degrees Celsius, which is used for lubricants. Next one is paraffin wax. Paraffin wax having the boiling range about 400 degrees Celsius, which is used in the manufacture of can. Boiling values not unknown. It is used for some road purposes. Next one is pitch. Boiling values unknown. Next, cracking. What is cracking? Cracking is nothing but higher hydrocarbons are decomposed into lower hydrocarbons with low boiling points. I already told petroleum is a mixture of hydrocarbons. So here we using higher hydrocarbon is decomposing. We get lower hydrocarbons with low boiling point, which is the main production of gasoline. Due to cracking, we get gasoline and diesel fuel. Cracking of petroleum, we get gasoline and diesel fuel. There are two types of cracking involved in petroleum. First one is thermal, second one is catalytic. What is thermal cracking? Thermal cracking is nothing but here we using high range of heat. Heat is used for the main process involved here. In thermal cracking, high temperatures and pressures are used to break the large hydrocarbons into smaller ones. I already told, always using higher hydrocarbon into lower hydrocarbon. Here, high pressure, instead of high pressure and temperature using to break the large ones into smaller one. Next, thermal cracking gives mixture of hydrocarbons with double bond alkenes. Already told, thermal cracking is a mixture of hydrocarbons, so it gives the double bonded alkenes. Thermal cracking is further classified into three types: steam cracking, hydro cracking. What is steam cracking? Steam cracking is nothing but high range of heat is applied. High range of heat is applied. Here, hydrocarbon is mixed with steam heated to, here using high range of temperature 700 to 900 degrees Celsius, and then cooled, we get steam cracking of steam cracking. Next, hydro cracking. What is a hydro cracking? Hydro cracking is nothing but mixture of hydrogen and heat is used. Here we using the temperature 250 to 400 degrees Celsius, we get the product. Catalytic cracking. What is catalytic cracking? Here we using some catalyst. Catalyst is the main process involved in the catalytic cracking, which is also used to break down the large hydrocarbon into smaller hydrocarbons. Here we using acid as a catalyst. One of the main catalysts used in catalytic cracking is acid. Here adding catalyst with moderate temperature and pressure. Here temperature ranges between 475 to 530 degrees Celsius. Pressure is used about 20 atmosphere. Here we have pressure maintaining is 20 atmosphere. Temperature is 470 to 530 degrees Celsius. Next one, synthetic petrol. Why synthetic petrol is needed? What is the purpose of synthetic petrol? Why we are using synthetic petrol? Nowadays we are using large automobiles and aeroplanes. So the demand is vast. So vast demand we use to synthetic petrol. So the need of petrol is important. That's why we are using synthetic petrol. In India, some places petroleum is manufactured. In North Assam, Gujarat, some countries also producing maximum petrol refineries. So oil field is not sufficient. So need of synthetic petrol is increased. So that's why we are using synthetic petrol. One of the, here two processes involved for producing synthetic petrol. First one is Fischer-Tropsch process. What is Fischer-Tropsch process? Here steam is involved. In all the process, steam is the main concept. Here steam is blown over red hot coke to get water gas. Water gas is a mixture of carbon monoxide and hydrogen. Nothing but it is a mixture of carbon monoxide and hydrogen. Here steam is using with red hot coke. Next, mixture with half its volume of hydrogen and then passed over the catalyst at 470 to 870 Kelvin under 1 to 100 atmospheric pressure. So here we are using half the volume of hydrogen and water. Catalyst at 470 to 870 Kelvin. Here we are using pressure is 1 to 100 atmosphere. So this is the main concept. Here we are using this pressure up to 1 to atmosphere. Catalyst having the temperature 470 to 870 Kelvin. Half of the volume of hydrogen and water is used. Next point is that to yield crude oil which is refined by fractional distillation as in the case of petroleum. So main concept is here we all the process we using crude oil which is distilled by fractional distillation, refined by fractional distillation. Next one is high boiling fractions are cracked into more gasoline. We already seen that we are using higher molecules into lower molecules. Here also we using higher boiling fraction. One of the we using high boiling fraction, we get more gasolines. Here X molecules of carbon monoxide and hydrogen, which gives mixture of hydrocarbon. It may be saturated or unsaturated with molecules of water. Various metals, oxides and their mixtures also used as a catalyst. Not only acid, here we using metals, oxides and their mixtures also used as a catalyst for Fischer-Tropsch process. One of the catalysts here using is cobalt. Cobalt is the main catalyst used in refining, cracking in petroleum. Here pressure maintained to 9 to 10 atmosphere, which having the high boiling fraction. So only we have using 9 to 10 atmospheric pressure only. To get a better yield of gasoline, reaction is usually carried out under atmospheric pressure. We want more yield of gasoline. We have to maintain the temperature and pressure under atmosphere. Okay. Next one, Virgius Processor. This is also one of the method to produce synthetic petrol. So Virgius Processor. Here what is involving the Virgius process is coal. In Fischer-Tropsch process also we have seen that coal is mainly used. Here also we are using coal. Coal is largely a mixture of solid hydrocarbons. There in Fischer-Tropsch process we using red hot coke. Here we using coal, mixture of, it consists of solid hydrocarbons. So only having solid hydrocarbon, not liquid or gases. Second, coal may be hydrogenated to produce low boiling hydrocarbons. In all the process we have seen that higher boiling into lower boiling points, high hydrocarbons are break down into lower hydrocarbons. Here also coal may be first coal is hydrogenated, then with a low boiling point hydrocarbon. Next, Virgius process for the manufacture of synthetic petrol involves a process. Here we produce a synthetic petrol. So this is the main process for synthetic petrol. Here we are using coal dust, which is in the form of paste. Here we are using the paste form of coal is used with heavy oil. We are mixing with the heavy oil or coal tar by incorporation of catalyst. Here the medium of using this catalyst as a medium. First coal dust is made into a paste and then mixed with heavy oil by incorporation of catalyst. Here catalyst is the major function of this process. Next, here we are using the heat to 670 to 870 Kelvin. We have to maintain the heat up to what? 870 Kelvin under 250 to 250 atmospheric pressure. Because low pressure is not needed, this is the pressure we need for this Virgius process, 200 to 250. Next one is hydrogenation of coal takes place and a product resembling crude oil is obtained. So all the process involved a hydrogenation of crude oil, hydrogenation of coal, whatever it is, we using hydrogenation, we get water, crude oil is obtained. Next, the crude oil is then fractionated to gasoline, middle oil, heavy oil. So further all the process, after process we get crude oil which is subjected to fraction. That is the fraction, due to fraction we get what? Gasoline, middle oil, heavy oil. Gasoline used, I already told gasoline used for some purposes. Middle oil, heavy oil also used as some purposes. What is reforming? Why reforming is important in petroleum? Why we use reforming in petroleum? Reforming is nothing but reforming is a process which uses heat, pressure and catalyst to upgrade naphthol into high octane petrol and petrochemical products. So here we seen that this is a process mainly uses heat, pressure and catalyst. So these three are the major aspects of reforming. What are they? Heat, pressure and catalyst. So heat is important, pressure also important and catalyst. These three involves in the reforming process. Why it is important means which upgrade the naphthol into high octane number. Here we using naphthol, which is also one of the byproducts of petroleum. So here we involving naphthol into high octane petrol and petrochemical products. Due to reforming we get the major products what is? Petrol and petrochemical products. Okay. Then knocking. What is knocking? Why knocking is important in petroleum? So what is the purpose of petroleum in knocking? It is nothing but in engine the fuel remaining after normal combustion ignites explosively by high pressure and temperature produced from normal combustion. So what it state means, in engine Sometimes all the fuels are not completely burnt. Some of the fuel remaining in the combustion. So it sometimes causes explosion. So we have to control this. We use it for knocking. Knocking is the main process of petroleum. Here high pressure and temperature produced from normal combustion. Normal combustion, high temperature produces. So we have to use knocking for the, to prevent what? Explosion is, to prevent explosion we using knocking. Next, mixture is fired by means of spark from spark plug. So due to explosion, some fire can be explode. So it will affect the environment. So that is why using some spark or spark plug. Next, for maximum efficiency, the fuel must be highly compressed before firing. So we have seen that maximum efficiency, fuel must be highly compressed. Why fuel must be highly compressed? Because high compression only maintaining the explosion. So that is why using high compression of fuel is used before firing. Before firing, we use a high compression. Next, if the ratio of compression increases, the point is reached. That point is called knocking. After that, after the process, some ratio increases in the knocking. That point is called knocking. On sparking, all the fuel does not burn smoothly. So I already told some explosion occurs due to the some remaining fuel not completely burnt. So all the fuels not completely burnt smoothly. It causes some sound. That explosive, it causes some explosion. That a violent sound is called knocking. It burns with explosive violence, giving rise to a metallic rattle. It is called some worst sound, that is called knocking. Metallic rattle called knocking. It burns with explosive violence. Violence means it causes some exhaust sound. That sound is not audible to ear. So that is called knocking. Next, prevention of knocking. Why prevention is important in knocking? So here prevention, what are the steps involved in prevention? Knocking can be minimized by the following methods. What are the methods involved is, here we are using anti-knocking agents. One of the main anti-knocking agents is TEL. TEL is what? Tetraethyl lead. Here we are using tetraethyl lead for the anti-knocking properties. Tetraethyl lead, which when added to gasoline minimizes knocking. If we added in knocking to TEL, it will minimize the sound. Knocking is nothing but it causes some explosive sound, violent sound. It will reduce the sound. It moderates the combustion of gasoline. So sometimes it causes some high combustion. If adding TEL, it will moderate the combustion. So it burns smoothly. Okay. Next, it leads to the deposit of lead metal in the engine. So due to addition of TEL, it containing lead, it contains metal. So it will deposit in the engine. So due to deposition, what will occur in the engine? Some corrosion will occur. It will damage the engine parts. So it is the main disadvantage of TEL. So for this purpose, we are using ethylene bromide. What is the purpose of ethylene bromide in anti-knocking? Because we are using TEL. In TEL, lead is present. So the metal will harm the engine, also corroded the engine. So due to prevent this, we are using the ethylene bromide, which is mixed with leaded gasoline to prevent the deposition of lead. So ethylene bromide is main important for the decomposition of lead in the engine. Sorry, deposition of lead in the engine. Next, the metal is converted into lead bromide, which escapes with exhausted gases. Here, the metal, what is the metal? The metal is lead. Here it is converted into lead bromide, which escapes with the exhausted gases. So the gas is, I already told that the sound comes from very explosive in nature. So that is why here we are using conversion. Next, we see about uses. What are the uses of tetraethyl lead? Which having the enhance the octane rating. Enhance means nothing but it increase the rate of octane number. Okay, used to increase the octane number rating like gasoline by raising the temperature, pressure and atmosphere. So it will increase the temperature, pressure and atmosphere. Enhance means nothing but increase the octane rating by raising the temperature, pressure and atmosphere. It also reduce the engine knocking, which auto ignition occurs. What is mean by auto ignition? It will sometimes it will occur selfly in nature, not to some to ignite. It will automatically self ignition occurs. So main uses of tetraethyl is it will control the auto ignition. So next we see about octane rating. What is octane rating? Why octane rating is important in petroleum? Which is used to describe the anti-knock qualities of a sample. We already seen about the anti-knock of petroleum, anti-knocking agents. So further we have to see about the octane rating. Main concept is it describe the qualities of a sample. Where here we using crude some samples. So it mainly describe the anti-knock qualities of which sample we using. Crude oil, gasoline, heavy oil, whatever it is. Here it describe the qualities of a particular sample. Next, higher the number, lesser the tendency of gasoline to knock in a high compression engine. Here we using the tendency of gasoline to knock in a high compression engine. Increase in number, it will tendency to what? Lesser the gasoline. So high compression is here needed. Next, octane rating is done considering the octane number of isooctane 100. So here isooctane for the octane number is 100. Next, cetane number. From the above discussion we see octane number, here we see cetane number. What is the difference between octane and cetane number? Octane number we see that qualities of a sample, describe the qualities of a sample. Here qualities of a diesel fuel. Here quality of a diesel fuel is exposed in terms of cetane number. There qualities of a particular fuel or sample. It describe the quality of the sample. Here we using fuel, diesel fuel expressed in terms of cetane number. What are the importance of cetane number is, which is used for predicting the ignition of engine, how it ignites. Importance. Next point is cetane rating is done considering ignition of cetane. How it is considered means here ignition is completing, the rating will be considered as how it is ignited due to cetane rating. Next, flash point. What is flash point? What is the purpose of flash point in petroleum? The minimum temperature at which an oil gives off enough vapor to form explosive mixture with air is called flash point. Here we already seen that all the process involved is high temperature, higher hydrocarbons, all need is high. Here we are using only minimum because minimum temperature only gives enough vapor. Here also explosion occur, but what? Mixture with the air, it will spread, sometimes it will mixture with the air is called flash point. That particular point is called flash point. Here we are using minimum temperature, it gives enough vapor to form explosive mixture with the air is called flash point. Thank you.